get in.
Very carefully. Stargate highway.
This is the biggest monitor.
And it gets really hard to find that cursor.
All right, rad. So this is something that me and Hugo were hacking on this week, and it starts with the bottom and gets up to the top, nearly to the top. We've got about as far as about halfway through highway stuff. But I will explain what these things are again, just in case you didn't get it when I first talked about what I was going to do this week. Anyway, stole this off the IPLD site, just to recap. Canonical is like a canonical ordering of blocks within a car file. So the idea that there is a way that you should order blocks, and it's basically depth first traversal order. And that gives us some cool properties. But like this is just car file is basically just this is the DAG, and then it gets put into the, and this is kind of how it would look in canonical format, basically. But there's a header and then there's the blocks, which is super cool. So yeah, block order within car files, and what we've got for that is like a function which will look at a car file and validate that it is in canonical format or not. But also a function that will take a car file, convert it into that format, and then spit it out again, which is great. And why is that good? Well, okay, let's get to that in a sec. But this is carv2. Like you can see, it's got basically a carv1 in it, but it's like wrapped by some extra data, which is like this v2 pragma. V2 header is the interesting bit, and that basically tells you like, where does the carv1 start? Like, what's the offset from the start of the file that the carv1 starts, and where does it end? And also, what is the offset from the start of the file where the index starts? And the index in carv2 is basically, it's actually configurable, so you can have like multiple different types of index. There's two at the moment, but the idea is like, for those two indexes is basically like, where are the offsets within carv1 for each CID, so you can really easily like seek to the right place and get the CIDs out of like the car. The idea that the idea that I had was that rather than have this kind of CID index, we have like a more intelligent index, which is like inspecting the DAG and pulling out like all of the paths, the IPLD paths that are within it, and using that as the index. And so our path index format looks kind of like this. It's like the path, so like slash, my slash folder slash, image.png. The CID for that piece of data, the offset within the carv1 file, like where can you find it, and how big that is. So that's kind of useful because this is kind of a key thing, is that because it's in this canonical order, like you can literally just say, get me a byte range between here and here, because everything between here and here is all of the blocks you need for that particular file. And you can actually do the same with like directories. So like if you've got a directory with many files in it, then you also get like a directory which is like start a directory, but also like the length is the end of all of the things within that directory and any subdirectories as well. So it's kind of cool for like, you can use the index for directory listings, but also like directory sizes and file sizes and stuff, because you kind of know, well, it's about the same, there's some overhead, but you get an idea anyway. And so what that looks like actually when it's serialized is like the var is like a number that describes how much more you need to read, because the path is like variable length, so you need to know how much to read. Var int for the CID, not strictly required, because CIDs actually do, in the multi-hash I think they specify how long that is, but it's just easier, because then I don't have to like slice off like the version 1 of the CID. Anyway, stuff. And then two var ints for the offset and offset length. So that's what the path index format looks like. So then we've got like this way of transforming carv1s into this carv2 with this index, where I can literally just look at the index and go, where's my file, and pull out a sub car from a from the car that has been indexed essentially. So you can pull out bits of it, and that's why and that's kind of what's needed for this idea of the highway. Actually, hang on, let me just explain this. So for this path index thing, we've got a way of taking a car and creating a car v2 with this index at the back. We've got a way of like reading that index, so it will look at the car v2 header, find out the offset of, look at the car v2 header, find out the offset of the index, go to the index, read the index, and then you have like all of the entries in that car. And we also have a facility to, like, once you've read the index, then go to the right place in the car file, and like it's just read bytes basically, and essentially because the index has the CID of the file in that path, it's really easy to create a sub car because you just need a car v1 header, which is like the root, the CID. Then you just stream out the blocks. Like there's nothing else to do. It's real easy. So anyway, yeah, the highway is like an IPFS gateway, but it's just for car files, and it's what needs this. So when you go to highway.car/CID, it gives you back a car file for that whole CID. That's like everything. But the interesting thing is that in the highway, the cars are in canonical format that you get back as well, because they've all been indexed so that you can do stuff like /pug.png and get a car file, which is just that file, which is within this bigger car, and return that. And so we got to a place where, so the idea is like we've got in with free storage, dot storage, lots of cars in S3. In S3 you can do like byte ranges, and this is what you kind of need to be able to do. But we also need that information about what is in there, so that we can pick out the bits that we want and serve them from a highway. And then essentially from the highway you build something on top of the highway, which is the Stargate, as I called it, and that basically ingests the car and does a UnixFS export on it to give you back the actual file. And the cool thing about the UnixFS export is that you can kind of stream it because the blocks are in the order that you next need them. Like there's no like go to a block store, get a block out and serve that. It's like just keep taking them in and spitting them out, because it's exactly what you need next. So this should be pretty trivial to kind of implement. So yeah, we did that. We got that far, but we didn't have time to do that. Anyway, so let's do the demo. I don't know how this is going to work with this size. Okay, here we go.
Your UnixFS.
Yeah, it's not gonna work.
No?
Well, we can make it work.
Make it super big.
That's going to be fun when you go back to just
Is Carnonical a thing for all cars or UnixFS cars?
What I didn't say is kind of interesting is that when you create this index, you need to know like the DAG and what's in the DAG, because you need to decode the blocks, because you need to know what paths are there. But like when like highway is streaming stuff back, it just reads the index and then it's literally a byte range, so it doesn't need to interpret the blocks in any way. It just streams them back. It doesn't have to have any codecs, need to know about any code. So yeah, it is UnixFS right now, but it can be like anything. It's any IPLD data that you can pass through. It doesn't.
Well, no, you wouldn't need to parse out the CIDs from the blocks wherever you can find them. Right? 'Cause
When you're creating
the car
it?
range,
What?
the car range though has the CIDs in for a block, right? So you would need to parse those out if you want to return the file data. Or are you saying you're just returning block data?
On the Stargate level?
You just return the
Oh, okay, I see. Okay.
like on the Stargate level, yeah, you can do that, but from highway where you're just returning cars and it's just byte ranges of blocks.
Yeah. By ranges of blocks. Yeah. Okay.
That's fine.
So
So
can I ask, when in your index, when you say start and end index of the path, so it spans multiple blocks?
yeah, it can do, yeah.
That's why you can do the directories, and you get like the size of the directory on the directory entry in the index.
Because everything is
Is the, like that path includes all the blocks for
everything.
all sub
Yeah.
Yeah.
Oh, directory size as in the DAG size.
yeah, directly
Yeah.
directly DAG side.
But it's not. It's more than
Oh.
DAG size because it's also like varint CID,
CID.
varint block data. Like it's.
What happens when things get deduplicated though? You gotta repeat them?
So yeah, you've got to repeat them. I did think about this, but I think it's not worth explaining it right now, and I certainly haven't implemented anything. So anyway, this is the demo. I've got this directory on my desktop called Stuff. You can barely see it because the monitor's so huge, but it's got some GIFs in there. Got like 3 pictures of my favorite. They're not actually GIFs, but anyway. And then some recipes. They're just text files. They're just markdown files with some recipe data in it. And what I can do using the regular IPFS car utility that Vashko and Ollie built is I can create a car from my stuff directory, and I can go stuff.car, and that will hopefully create me a car, and then I can do IPFS car list stuff.car, and it will show me like, oh, okay. Font a bit smaller. And it's just showing what's in the car. Anyway, that's not what I'm here to show. I've got a highway command line utility, which is like index, and it will index my stuff.car, which involves A, transforming it into canonical format, and B, adding the index, making it a car v2 and adding the index. So stuff. I'm going to say indexed.car. So that creates the index, and then I can do highway inspect. Yeah, stuff indexed. Oh man, okay. And so this is actually going in and reading the index, and you can see like all of the paths that are in the index, the CIDs to each one of these files, but also like the offset within the file and the total length of that. And so that's just reading the index data, and then we also have highway export. And I can what's kind of cool is I can export like a directory, like just the GIFs directory, and this will create me a car v1 file of just the GIFs, and so I can do like gifs.car here. Oh, I need to give it. Sorry, I need to tell it which car to actually pick it out of. So it's and then the GIFs should be on my desktop.
Not made the cut.
Where did they go?
Just that way.
It's there,
Stuff car.
Oh yeah. So we've got gifs.car, and then I can do IPFS car unpack gifs.car, and that will create the folder, which is here with my 3 GIFs in it. So they
A subcar.
Clown car.
and you can do it with individual files and everything. But that bit is essentially what the highway does. Is it will pick out bits of the car and then serve them back, and that's it. Cool. That's the demo. Sorry it took so long.
I should do it. Do you have that one?
No, you should do it. So the new